Earth has just been struck by the most powerful solar storm in over 20 years, and the cosmic chaos is far from over. Recently, a colossal blast of solar energy hurtled towards our planet, igniting breathtaking auroras that painted the skies from Tasmania to Britain in vibrant shades of green and red. These mesmerizing light displays, while enchanting to skywatchers, signal a more ominous threat lurking above us. Satellites and power grids, the invisible lifelines of our modern world, now face the brunt of this solar tempest. As the storm continues to rage into the weekend, experts are on high alert, monitoring potential disruptions that could ripple through global communication networks and electricity supplies. Imagine waking up to a world where your GPS fails, your favorite TV shows are interrupted, or, worse yet, a blackout blankets your city. Stay tuned as we delve into the details of this solar storm's impact, the science behind these awe-inspiring auroras, and what you can expect in the days to come. The skies are putting on a show, but the true drama might be unfolding right here on Earth. But before we continue, if you are fascinated by the incredible discoveries and spectacular wonders of the universe, be sure to subscribe to The Rocket to continue exploring the cosmos with us. For years, scientists have warned us about the sun's fiery temper, likening its powerful eruptions of radiation and plasma to cosmic tantrums that, if aimed at Earth, could send our modern world into a tailspin. Picture it: a supercharged atmosphere, a scrambled magnetic field, and the terrifying prospect of hitting a global reset button on much of our technology. This isn't just sci-fi, it's what a sufficiently intense solar storm could do. Satellites could be nudged out of orbit, submarine cables, the very veins of the internet, could short out, and power grids might collapse, plunging cities into darkness. A few weeks back, our planet faced one of the mightiest solar outbursts in 20 years. It was like the sun decided to throw a colossal, fiery party, and Earth was the unwitting guest of honor. Despite this cosmic onslaught, we emerged relatively unscathed, thanks to years of meticulous planning by both the public and private sectors. The storm has subsided, but that pesky solar region isn't done yet. It's still hurling monstrous flares, luckily now aimed away from us thanks to the sun's rotation. So, while we've passed our biggest test yet, experts caution against getting too comfortable. The question isn't if we'll face another solar storm, but when. This is a success story, says Sean Dahl, a space weather forecaster at the National Oceanic and Atmospheric Administration's Space Weather Prediction Center, SWPC, in Boulder, Colorado. However, he quickly adds that the weekend's storm was nowhere close to the power of the most intense historical events. So, is it time to kick back and relax? Heck no, he quips. The drama began on May 8th, when ground and space-based telescopes detected multiple explosive outbursts from the sun headed straight for Earth. But it started even before that. The first signs of the solar storm began late on May 7th with two powerful solar flares, setting the stage for a cosmic spectacle. Between May 7 and 11, multiple intense solar flares and at least 7 coronal mass ejections, CMEs, barreled towards Earth. Among these were 8 X-class flares, the most powerful type, with the strongest reaching an impressive X5.8 rating. And just when we thought the sun had calmed down, it unleashed an even mightier X8.7 flare on May 14th, the most powerful of this solar cycle. These CMEs, traveling at speeds up to 3 million mph, arrived at Earth in a series of waves starting on May 10th, sparking a prolonged geomagnetic storm that reached a G5 rating, the highest on the geomagnetic storm scale, unseen since 2003. The CMEs all arrived largely at once, and the conditions were just right to create a really historic storm, said Elizabeth McDonald, NASA heliophysics citizen science lead and space scientist at NASA's Goddard Space Flight Center. As the storm hit Earth, it treated us to spectacular auroras visible around the globe. Even places like the southern US and northern India, typically too far from the poles to enjoy such displays, witnessed these celestial light shows. The strongest auroras dazzled on the night of May 10th and continued throughout the weekend. Thousands of reports submitted to the NASA-funded Aurorasaurus citizen science site are now helping scientists study and understand this extraordinary event. Cameras, even standard cell phone cameras, are much more sensitive to the colors of the aurora than they were in the past, McDonald explained. By collecting photos from around the world, we have a huge opportunity to learn more about auroras through citizen science. By the Disturbance Storm Time Index, a measure of geomagnetic storm strength dating back to 1957, this storm was on par with the historic storms of 1958 and 2003. With reports of auroras visible at latitudes as low as 26 degrees, this storm might even challenge some of the lowest latitude aurora sightings recorded over the past 5 centuries. However, scientists are still assessing this storm's place in the record books. It's a little hard to gauge storms over time because our technology is always changing, said Dolores Knipp, a research professor in the Smead Aerospace Engineering Science Department and senior research associate at the NCR High Altitude Observatory in Boulder, Colorado. Aurora visibility is not the perfect measure, but it allows us to compare over centuries. The SWPC swiftly issued a warning. A severe space weather event was imminent. At least 7 of these outbursts, known as coronal mass ejections, CMEs, slammed into our planet, delivering billions of tons of solar plasma. It was like the sun had punched Earth in the face, leaving our magnetic field ringing and the upper atmosphere swollen, almost as if bruised. This geomagnetic storm, the most severe since 2003, posed significant risks to global infrastructure but also treated much of the world to stunning auroral displays. The skies danced with light, a beautiful reminder of the sun's power and our planet's fragility. At present, it's hard to say just how close we came to catastrophe during the solar storm. Many companies, from grid controllers to satellite operators, are tight-lipped about the storm's impact. Daniel Welling, a climate and space scientist at the University of Michigan, explains, "They don't want to look like they're vulnerable. Satellite operators have to insure their spacecraft, and that can be very expensive. Despite this, various scattered reports are already shedding light on the storm's disruptive effects. Flight trackers revealed airlines were rerouting planes to avoid Earth's poles, where cosmic radiation from the storm could have turned flights into interstellar thrill rides. Transpower, New Zealand's state-owned enterprise running the nation's electric power, preemptively switched off some circuits across the country on Saturday, May 11th, ensuring no impact on New Zealand's electricity supply. In Minnesota, the firm Minnesota Power opened capacitor banks to brace for the storm. Similar precautions were likely taken worldwide, although the secrecy makes it tremendously difficult to gauge their effectiveness, Welling says. Geomagnetic storms can also mess with GPS signals. In the first 2 weeks of May, multiple farmers reported issues with their GPS-guided farming equipment. In South Dakota, one farmer's tractor started driving in circles during the storm, and others shared outages on social media. "Our GPS on both the planter and the strip tiller were absolutely bonkers today," one commenter wrote on Reddit. Another noted, "I saw this post and looked, no GPS." Landmark Implement, a John Deere dealership, advised customers to turn off GPS devices on their farming equipment due to the storm's impact on base station corrections. Landmark declined further comment. The storm posed hazards in space as well. NASA said the 7 astronauts on the International Space Station were mostly safe, but had to take precautions. The crew was told to avoid lower shielded areas of the space station out of an abundance of caution, says Sandra Jones, a spokesperson for NASA's Johnson Space Center. Certain areas provide less protection from radiation, such as the airlock, while other areas, such as crew quarters, offer enhanced protection. The crew was never in any danger, and the energy levels have since decreased. Other satellite operators weren't as lucky. In the UK, Sen, a company that streams 4K video from a satellite in low Earth orbit, powered down its spacecraft for 4 days to avoid damage from the storm, such as fried circuit boards or electronic failures. It was in an idle mode, says Marcin Bujar, spacecraft operations lead at Sen. We just kept the bare minimum on, the flight computer and radio receiver. This prevented the satellite from carrying out tasks like observing flooding in South America and wildfires in Canada. It definitely had an impact, Bujar admits. Even larger satellite constellations, like SpaceX's massive Starlink fleet, weren't immune to the storm's wrath. With over 6,000 satellites beaming the internet from low Earth orbit, the true extent of the impact remains murky. Elon Musk, SpaceX's CEO, kept his message on X brief and Musk-like, noting the satellites were under a lot of pressure, but holding up so far. Flashback to February 2022, when a similar geomagnetic storm sent 38 freshly launched Starlink satellites plummeting back to Earth due to excess atmospheric drag. This time, however, Starlink managed to avoid such drama, launching 23 satellites into a higher, safer orbit. Sangeetha Jyothi, a computer scientist at the University of California, Irvine, noted some increased delays in Starlink's ground communications, but no catastrophic failures. We can see some impact, but it was not disastrous, she says. Ground-based internet infrastructure, especially the critical submarine cables, remained unaffected by the storm's relatively modest strength. The Hubble Space Telescope, although safely above Earth's surface, felt the storm's effects keenly. Normally descending earthward at a steady rate due to drag, the storm doubled Hubble's rate of orbital decay to about 80 meters a day instead of 40 meters a day, McDowell says. Claire Andreoli, a spokesperson at NASA's Goddard Space Flight Center, indicated Hubble is expected to burn up in Earth's atmosphere in the mid-2030s. However, increased solar activity could hasten this timeline, cutting short the operational life of one of the most advanced telescopes ever built. It's kind of unfortunate to be at the whims of the sun, remarks J.J. Hermes, an astronomer at Boston University. Overall, despite the storm's initial bluster, Earth managed to weather this solar tirade without succumbing to apocalyptic scenarios. I was a bit surprised how much of a nothing burger it was, McDowell muses. But don't start popping champagne just yet. While this storm was significant, it's not the worst we can expect in the coming years. The sun is gearing up towards the peak of its 11-year activity cycle in 2025, promising potentially more intense solar storms. Measuring the strength of geomagnetic storms involves various factors both on Earth and in space. A rough measure can be given in nanoteslas, NT, with Earth's magnetic field baseline at 20 NT. Historically powerful storms, like the Carrington event of 1859 and the New York Railroad storm of 1921, hit around 900 NT, with Carrington possibly reaching 1,750 NT. Last weekend's storm, while historic, was a relatively tame 412 NT. Even though this was historic, it was nowhere close to the level of 1921 and 1859, says Sean Dahl, a space weather forecaster. Over the past decade, the looming threat of solar storms has captured our collective imagination, thanks in large part to the tireless work of the Space Weather Prediction Center, SWPC, and other dedicated organizations. In 2020, the U.S. government took a significant step forward by passing the Promoting Research and Observations of Space Weather to improve the forecasting of tomorrow, ProSwift Act. This legislation aimed to develop formal mechanisms to transition space weather research models and capabilities to operations, according to NOAA's 2023 news release. This initiative has been a game changer. Sean Dahl from SWPC says it has ensured that space weather is treated much more respectfully. We are much more prepared than we were 10 years ago. This preparation was put to the test during last weekend's solar storm, and the results speak volumes. Enhanced space weather forecasts provided timely warnings about the impending solar barrage, allowing for well-coordinated protective measures, both in the U.S. and around the globe. The diligent work leading up to this event paid off as the storm unfolded according to plan, proving that we can effectively mitigate the impacts of even substantial solar storms. But let's not get too comfortable. The sun is like that grumpy neighbor who occasionally throws a wild party. This time, it was loud, but nothing got broken. Next time, we might not be so lucky. The real test will come with a much stronger Carrington-esque storm. Jonathan McDowell, an astronomer with the Center for Astrophysics, Harvard and Smithsonian, cautions, the sun is a powerful enemy. We haven't seen the worst it can do. As we bask in the glow of our recent success, it's crucial to remember that the sun's fiery outbursts are unpredictable and potentially catastrophic. The preparation and foresight that protected us this time around must continue to evolve. The cosmic ballet of the sun and earth is a dance of immense power, and we are but tiny dancers trying to keep in step. Will we be ready when the sun decides to throw its next grand tantrum? Only time and continued vigilance will tell. As we reflect on the awe-inspiring power of the sun and its recent cosmic tantrum, let's consider our place in the grand dance of the universe. With our technology advancing and our understanding deepening, one can't help but wonder, what celestial marvels await our exploration next?